So we have seen what is comparable. Now we are seeing what is comparator. Okay, I have told you the difference. Whenever we use default natural sorting order, there is comparable interface, and whenever we need to use our own sorting order, that is customized sorting order, at that time we use comparator interface. So let's see the points of comparator interface. The first one is it is used for customized sorting order and is available in java.util package. Fine. It has two methods, that is compare and equals. This compare method is the important method and equals is a dummy method. Equals, the method that is equals is present in object class, is also present in object class with the same name. Okay, this class has already implemented equals method. Fine. And every class that we create in Java inherits this class. Okay, so all classes automatically contains equals method implementation. Fine. So this is just a dummy method. Okay, it was created before. So the important method is compare method. Okay, it is similar to the compare to method we have seen in comparable. So in compare to we wrote object 1 dot compare to object 2, and here we are writing in argument form. So it returns negative if object 1 is smaller than object, that is object 1 comes before object 2. Positive if and only if object 1 has to come after object 2, that is object 1 is greater than object 2, and 0 if and only if object 1 and object 2 are equal. So this is similar to compare to method, and the second one is equals, that is same as object class equals method. Fine. So this is comparator interface. Now let me tell you how we do customized sorting using comparator interface in our coding. Okay, so we were here. So let me tell you how we actually perform customized sorting. So I will create another object of tree set class. This time I will pass integers. Last time I passed characters. So integer and tree set 1 equals to new preset, and here we will not use the constructor for default natural sorting, that is the first constructor, but we will use our second constructor of tree set class. Okay, our second constructor. I will pass my own comparator class, my comparator. Okay, I will pass my own comparator class. Now in this comparator class, what we will do in my comparator class, it will implement, this class will implement the comparator class, and since I am doing it for integer, I will pass integer. Okay, now it shows error because we have to implement the compare method. This is because of interface, correct? In comparator interface we have the compare method, and the class that implements it has to implement that method. This is the contract which they sign, interface and the implementation class. Okay, so we have to implement it. So public, and we have to implement this compare method. Okay, we have to implement this compare method. Let's see what we have to do. Now my sorting in default natural sorting order is nothing but ascending. Now I want descending. I do not want ascending, but I want descending. So let's see what will happen. So if I am inserting my elements, for example 2, 3, 1, 5, 4. So in default natural sorting order it will come as 1, 2, 3, 5 and 4. But in my customized sorting, I want this answer as 5, 4, 3, 2 and 1. Correct? This is descending and this is ascending. So how it happens when 2 comes in default natural sorting order, when 2 comes, now we are using default natural sorting order, so we are using the first constructor, so it will normally call the compare to method. So 2 comes, 2 is the first one, so 2 will become, now 3 will come, 3 will be compared, 3 has to come after 2, so it will simply return me true. Okay, that is the positive number. So 3 will come after 2, correct? 1 has to come before 2, so it will come before 2. Now 5 has to come after 2, so it will come positive. 5 has to come after 3, so it will become positive. So it will come here, and then there is 4, so it has to come after 2, it has to come after 3, it has to come before 5, so it will come here, and the tree will be balanced using the balancing algorithms. Okay, because this is a balanced tree. We want a balanced tree. Now what will happen is, so we have 1, 2, 3, 4 and 5, correct? So this will just print me 1, 2, 3, 4, 5. Okay, but now what we want 5, 4, 3, 2, 1. We want 5, 4, 3, 2, 1. So how it will happen? Just reverse. When object 1 is coming, and object 2 is coming, what we are doing, if 3 has to come after 2, return me a positive. For descending, just return a negative. Just that simple. Just opposite. Just do opposite of what we were doing in ascending order. So just do opposite in descending order. Correct? We will get our answer. So if object 1 is simply less than object 2, your object 1 is simply less than object 2. Here we return negative, but in descending we will return a positive. Okay, if object 1 is greater than object 2, in ascending order we return positive, but in descending order we will return negative. If they are equal, then we can do nothing, we will simply return a 0. So this is how descending order will be implemented. So the descending order is a customized order. Okay, it is not a default natural sorting order, we are implementing it. Okay, similarly you can do the same things for strings also, for alphabet also. You can do a reverse of alphabet, correct? So return a 1. Fine. Now else if object 1 is greater than object 2, return a negative value, correct? And else this both are equal, then return a 0. So now what will happen is, whenever I get my objects 1 and object 2, so instead of ascending I will get the answer as descending. Fine. So now let me add the elements. Okay, now let's add these objects. We can add preset 1 dot add and an integer 1. Okay, now let's add more values. So we will have 1 5 3 4 2, correct? Now the answer that we will get here is in descending order, not in ascending order. When we are in default natural sorting order, we use comparable, but when we are in customized sorting order, we will use comparator. So as you can see, we get a reverse order, that is 5 4 3 2 1. So this is how you can implement your own customized sorting. You can do this for strings also. Fine. You can also do that for heterogeneous elements. Just take a string, take an integer, compare their ASCII values, and you will get a heterogeneous objects too. You can try many number of things, because this is your logic. My work was to explain you how the comparator is used, comparator interface is used. This is how the comparator interface is used. So now what add method will do, for the default one, add simply calls compare to method. But for the customized one, now what add method will do, it will go to my comparator and it will execute this code. Whatever it returns, according to that it will give us the value. Fine. So this is the difference between comparator and comparable. Now you can experiment with it any number of times. Okay, now we have seen what is sorted set, we have seen comparable and comparator. Therefore I took tree set first, because we had to know that how these values are compared and stored. Okay, now we will see what is navigable set, the methods of navigable set, and we will implement those methods. Okay, so the next topic is navigable set. So navigable set was an interface. It is a child interface of sorted set, and the tree set implementation class implements both navigable set methods and the sorted set methods. Now methods in navigable set are, first one is lower, so it returns the greatest element in the set which is less than the given element, or null if there is no such element. Okay, now we have many of these methods, that is lower, flow, ceiling, higher, pole first and pole last. Okay, lower, flow, ceiling, higher, pole first and pole last. So now let me just show you these methods. Instead of talking and reading these points, you can write it down, obviously, with the help of coding. Okay, I will just show you these methods, not only these methods but the methods of sorted set interface also. So these methods are the methods that are specific to navigable set. Okay, but we also have methods of sorted set interface, correct? It is a child interface, so navigable set also have access to the methods of sorted set that we have seen in previous slides. Okay, so we will see all those methods also using tree set, that is the implementation class. So this is one example that I have taken. What I have simply done is, I have tree set, that is my class, integer, that is my type parameter, tree set, that is my reference variable, and an object, a default object. Since it is a default constructor, I am using a default constructor, so this is simply going to store the elements in default natural sorting order. For numbers, we will use simply ascending order. So when I just print this one, when I run this program, so what I will get 0 1 2 3 4 5 6 and 7. Fine. Now let's see one by one these methods, these all methods. So the first method that we will see are the methods of sorted set methods that we have seen in previous slides. So system.out.println, this was a method, the first. What it does, it simply returns me the first element. It simply returns me the first elements. So let's now run it and see the output. So as you can see, the first is 0. So first element is 0. Next is again a sorted set method. So this is the last. So this will return me the last element. This will simply return me last element. As you can see, the last element is 7. Fine. So the next is head set. What head set does, if you remember, head set gives all the elements that are less than 4. All the elements that are less than 4. So 0, 1, 2, 3. All the elements that are less than 4 will be given to me by head set. And what the tail set does, it gives all the elements which are less than the object that you passed. So from element, see, it is 2 element form and from element 3. Okay, so from element 3 to all the elements that are present inside the set. Okay, from element 3 to all the elements that are present inside the set. Now you can see the difference in here, that when I passed 4, it is not inclusive, but 3 is inclusive. 3 is inclusive. Okay, so it is less than 4 and it is from 3 to the end. From 3 to the end. So keep this difference in mind. Now the next one is system.out.println the subset. So subset between 3 and 7. In this case also 3 is inclusive and 7 is not inclusive. Okay, so here as you can see 3, 4, 5, 6, not 7. So 3 is inclusive and 7 is not inclusive. Now these were the methods of sorted set methods, correct? So navigable set also contains these methods because it is a child interface. Fine, but navigable set also have some specific methods for navigation purpose. Okay, the name suggests navigation. So we will have a method known as lower. We will have a method known as lower. So what does lower does it? As you can see, returns the greatest element in this set which is less than the given element. So I am passing some element, the greatest element which is less than this. Okay, so as you can see, I have passed 6. So in this set, the greatest element which is less than 6 is nothing but 5. In this set, the greatest element which is less than 6 is nothing but 5. Therefore, it returns me a 5. What floor does, it just small difference from lower. Greatest element which is less than or equal to. Either it has to be equal to or it has to be less than. So if I pass 7, so less than or equal to 7. Less than or equal to 7. So we do have a 7. So it will simply return me a 7 because it is equal to 7. Okay. So I can change this example. Okay, so let me get 8. So 8 is not in this set, but we have an element which is less than 8. Okay, which is less than 8. The greatest element which is less than 8 here in the set is 7. So the output again will simply be 7. Okay, as you can see, it runs and the output again is 7. Now we will do ceiling. So what is ceiling is, as you can see, they return the least element in this set which is greater than or equal to the element. So in here we were talking about less than, now we are talking about greater than. Okay, so in ceiling we have greater than or equal value, and in higher we have just a greater than value. Okay, returns the least element in this set which is greater than or equal to. Okay, greater than or equal to. So greater than equal to 5. So the answer in this one is simply going to be 5. Greater than equal to 5. So the answer is simply going to be 5 because we have an equal to condition 2. Now this was greater than 6. Higher is not equal to but greater than 6. Okay, so greater than 6, the element which we have here is 7. Only element that is greater than 6 in our set is 7. So the answer will be 7. Now we will see poll first. So what is poll first is, as you can see, retrieve and remove the first least element. Retrieve and remove the first least element. Okay, it will retrieve and remove the first least element. So let's see. It will retrieve and remove, that is 0. So it will return me a 0. Okay, and it will remove that from the set. It returns me a 0. And now let's see, after the poll function, what is my new tree set, because it also removes. It not only returns, it removes. So we have a, after poll first, as you can see, we now do not have a 0 in our set. We do not have a 0 because it is removed by poll first. Poll last does is the exact opposite. It will retrieve and remove the last element. Okay, not the last element but the last highest element. The last highest element. Okay, so now as you can see, the poll first will return me a 7 because the last highest element is 7, and simply now I will print the tree set. It has removed the 7 also. So my tree set now becomes 1, 2, 3, 4, 5 and 6. So poll first and poll last not only retrieves but they remove also. So they have removed the first and the last one. So these were the methods in my sorted set and navigable set, and I have implemented these methods using the tree set. I have already implemented these methods. I have used those methods using the tree set. Okay, reference variable. So this was my set. Now I completed with list and we have completed with set. Now the only thing remaining in the only thing remaining in collection interface is queue, and then we can move on to the map interface. Okay.